infiltration device is a basin or trench that channels stormwater runoff directly into subsurface soils where it is treated before it enters the groundwater. When choosing a site for an infiltration device, engineers must take into consideration zoning classifications, setbacks, property lines, building foundations, and other such structures. Additionally, infiltration devices should be situated on level ground, void of steep slopes or previous excavation. Infiltration sites must also be free of spills, toxic substances, contamination, or ongoing groundwater remediation. DC Code requires that a District of Columbia registered professional engineer, soil scientist, or geologist complete a geotechnical report. More information about the report's requirements can be found in the District Department of the Environment's Stormwater Guidebook. Soil boring and soil percolation tests are conducted to determine if infiltration practices are suitable for the proposed development site. A soil percolation test determines the permeability of soil by calculating the rate at which fluid moves through it. These findings must be submitted with a geotechnical report.
Say I got a percolation test site in southeast Washington, D.C., in the Oxon Creek watershed, where infiltration devices have been proposed for the stormwater management practices. This percolation test was conducted on this site right here as part of the feasibility to determine if this type of practice would work for the soils and where the groundwater is, etc. This test was conducted by geotechnical engineers, and they prepare a report for our office along with percolation test results. This pipe has to remain on site until such time that the stormwater device is built so that they can put the infiltration facility within 50 feet of this test hole. And generally what's done for the test is pipe is set in the ground and then it's filled up with water and allowed to stand for 24 hours. And then they come back and pour more water into the perk site and then test how long it takes for water to infiltrate 1 inch in an hour. And generally what the person would do is they would have some sort of method of measuring where the water was at the beginning of the test by simply sticking a steel tape or some other type of device, something maybe a little more sophisticated than a steel tape. Find the bottom, measure it, and then come back an hour and measure that as well after tracking the distance, the height of the pipe is above grade. And these pipe has to remain here until such time the device is completed.
The soil percolation rate must be no less than 1 inch per hour. A higher number or greater percolation rate indicates a more permeable soil, thus water moves more quickly into the subsoil. If groundwater is detected within 2 feet of the proposed bottom of the infiltration device, then another site may be required. Correctly sizing the infiltration device is critical to its ability to treat and release stormwater into the subsoil. It must be able to capture the first half inch of stormwater, then release that water into the subsoil within 72 hours of the rain event. The infiltration device should be filled with stones from 1.5 to 2.5 inches in diameter. When placed in the infiltration device, the stones leave empty spaces between them. These empty spaces are called voids. To determine the storage space available in the stone-filled infiltration device, we must know the void ratio. For example, a proposed development project 100 feet by 50 feet has 5,000 square feet of imperviousness to be treated, and let's say that the proposed infiltration area was found to have a percolation rate of 2.5 inches per hour. First, the drainage area and volume required to treat is calculated. In this case, the area is 5,000 square feet, 50 feet by 100 feet, times half an inch of rain, divided by 12, because there are 12 inches in a foot, gives us 208.33 cubic feet of volume required to treat for the first half inch of the proposed development site. The engineer would then propose a length, width, and depth for an infiltration device that can meet the other requirements for the site, such as distances from the building or other utilities. These are called setbacks. For example, 20 feet long by 10 feet wide by 5 feet deep. It's important to also remember that the depth of an infiltration device cannot be deeper than the original percolation test and must be within 50 feet of the test. A trench this size would have 200 square feet of surface area available for infiltration. At a rate of 2.5 inches per hour, this can be expressed as length times width, or 200 square feet times 2.5 inches per hour divided by 12 inches equals 40 cubic feet per hour. A 20-foot long by 10-foot wide by 5-foot deep infiltration device with an infiltration rate of 2.5 inches per hour can be expected to treat 208 cubic feet of water in 5 hours, well within the required 72-hour drawdown for an infiltration device in the District of Columbia. Stormwater must flow into the infiltration device without carrying sediment or other things that may clog it. This may be achieved by pre-treating the area with grass swales or water quality catch basins. These devices reduce the amount of suspended solids and particles that will cause the infiltration device to fail over time. Many different types of delivery systems may be used to deliver stormwater to infiltration devices. Some examples include above-ground infiltration, or directly draining stormwater into the underground device through a stone surface. Stormwater may flow from catch basins and drains and be delivered via an underground pipe. Or stormwater may drain directly from rooftop downspouts into an infiltration best management practice, or BMP. The prevention of sediment intrusion and stormwater runoff into the infiltration device is perhaps the most important factor to consider during construction. A sediment flow into the system during construction may cause the device to fail. The infiltration practice should be maintained as inoperable until all grading and landscaping has been completed and the final erosion and sediment control measures have been installed. When constructing an infiltration device, we also consider soil compaction. Soil compaction occurs when weight is applied to soil, causing it to compress and ultimately reduce pore space. Compacted soil will not infiltrate water properly, and restoring pore space can be difficult. Contractors and engineers should consult with district stormwater engineers prior to using filter cloth and follow the guidelines in the approved stormwater plan. Woven monofilament filter cloth may be installed on the top, sides, and bottom of the infiltration device, but must meet district code requirements. Improper filter cloth may clog and prevent infiltration. A 6-inch layer of washed sand is the preferred bottom filter layer. An overflow pipe is required and must be at the correct elevation so that overflow can drain by gravity to a public sewer, wetland, or other stormwater device. Observation wells are also required by code and allow drainage time to be observed. To function properly, wells must be installed to the depth of the infiltration device and extend 18 inches vertically above the ground. Caps must be installed to prevent blockage or other surface water from flooding the infiltration facility. They should remain intact and unobstructed except during inspection. Prior to the final connection and placing the stormwater infiltration device online, a district stormwater inspector must perform a final inspection. As with the construction of all permitted stormwater management or stormwater BMPs in the District of Columbia, the building permit applicant must notify DDOE at least 24 hours prior to the construction of any stormwater device to schedule an inspection. Additionally, inspectors may require supplemental inspections during construction of the stormwater BMP. No permitted stormwater BMP is complete until a final inspection has been conducted, and what is known as an as-built of the completed facility has been submitted to DDOE within 21 days of the final inspection for review and approval. After the as-built plan has been approved, the building permit applicant receives a final approval notice for the completed stormwater BMP, and a maintenance and operation inspection will be completed within 1 year. For further information regarding low-impact development practices or the RiverSmart Homes program, please contact the District Department of the Environment at 202-535-2240, Monday through Friday between the hours of 8 a.m. and 4:45 p.m. or visit us online at green.dc.gov.